Hey guys, what's going on? Let me try and fix this a little bit. Okay, what's up guys? Garrett here. What's going on? Welcome back to another video. In this one, we're going to be continuing on with our distributed systems series, if you want to call it that. And we're going to be talking about sidecar pattern. But really quickly, one of the comments that was brought up in the introduction to this series noted that the person actually didn't know what distributed systems are. So just wanted to let that person know, if you're watching, hopefully you are, that and also for anyone else watching down the road, if you don't know what distributed systems are, I'm going to come out with a video kind of explaining that, but this one I had already been working on, and so I just wanted to get it out there because I think it's useful knowledge. So like I said, in this video, we're going to be taking a look at what's called the sidecar pattern. Let's just jump into it. So what is the sidecar pattern? The sidecar pattern essentially is two containers. The first container is our main application, and this could be the application that you've already written, right? And then the container number two is what's called the sidecar. And the idea here is that the sidecar is essentially boosting or augmenting the behavior of the main container. Let's say, for example, your main container was a really old application that you want to kind of modernize. A sidecar might be a really good way to do so. So let's kind of take a look at how exactly that might work. And I forgot I have this picture here. This is kind of what I always think of when I hear of the sidecar pattern, so hopefully that helps. All right, let's talk about some examples. The first one is an application container that accepts HTTP, but we need it to accept HTTPS. Let's say that we have a website service kind of running here. Let's say it's an API, for example, and this API is old. Maybe it's 10 years old, 20 years old, whatever it is. But for whatever reason, it only accepts HTTP requests. And as we all know today, with security and all that fun stuff, we need HTTPS. So instead of going in and kind of digging through this old or legacy application container and kind of figuring out how to really build it up so that it is HTTPS compliant, if you want to call it that, we might say just create a sidecar, right, an additional container, which is a web service in this case, in the example that we're giving here, and it would just accept instead HTTPS requests, and then basically forward those requests as simply HTTP along to our main application container so that we can kind of still use everything with a minimal amount of effort. Another example is, let's say that we have a legacy application that deals with configuration in a manual way, right? So in other words, someone needs to actually go in, log into the system, and basically edit whatever's there, and then maybe restart the system so those configuration changes take effect, or however it works, right? Let's say that for the purposes of, for example, cloud native, which is something else that we'll get into way down the road, but cloud native, we want these things to be done automatically. So what are we to do? Well, one thing that we could do is we could containerize our legacy application. Maybe it wasn't containerized before. We could containerize it and then have it, perhaps it looks in a specific directory for the configuration file, right? And then we could have a sidecar container, which basically is a new application that allows us, or not us, any person really, to go in and automatically set up some configuration, right? So that it, connects to an API, or I don't know, whatever it is, but it automatically configures itself in some way according to, whatever requirements are kind of laid out, right? And then what it does is it might share a directory with the original application container, so that we can still kind of have our manual configuration, but do it in a more automated way. Note to self, I'm really kind of realizing that I need some pictures here, so apologies if I don't have any visuals and it's kind of hard to follow what I'm talking about. In my next video, I'll make sure to have some visuals, or at least more visuals than I already do. Another example might be that our that our application container doesn't log the way that we need it to. So let's say that our logging system, our monitoring system for our our entire distributed system expects logs to be in a certain format. We might, let's say, have a sidecar, which is like the log aggregator, that might take the logs from all of these different systems and then kind of format them the way that they need to be formatted before, you know, actually storing them or sending them to our monitoring software. Okay, so let's talk about containers here. I know that I've mentioned that a lot, and containers are kind of the building blocks of distributed systems, which I believe that I've mentioned in the past video. I'm pretty sure I did. But if I didn't, my apologies. Containers are the building blocks of distributed systems. And so there's a couple things that we need to kind of keep in mind when we are building our containers and when we're deploying them. The first is that we should parameterize our containers. Now, what does this mean? This is kind of similar to functions. Actually, it's really the same thing as functions, right? With a function, this is code that's written in Go, by the way. We might have, let's say, this greeting function, which takes in a name as highlighted by the red, right? And then that function, when we go to run it, we might pass in the name Garrett. And so the output of this would be hello Garrett, right? Because that's what I'm passing in. That's getting its name is being substituted with the value of Garrett, right? So the parameters here are right there, right? Now, what happens when we try to do this with a container? Well, it's kind of the same thing, right? So we could pass these parameters to the container when we go to run them using environment variables. And so we might say that the name is still Garrett, and we're going to run the container greeting, which then would simply, I don't have the code example here, but essentially what would happen is that this name, we would need to do the code a little bit differently to be able to get the environment variable, but nevertheless, the name Garrett would still be passed to our code, and we could use it much in the same way that we, you know, use functions. And so basically we're allowing our containers to kind of be dynamic based on the environment that they're living in or that they're operating in. Let's talk about the API layer, because this is really, really important. Now, we might have a container here, right? And this is our application container. And then we have the internet. And this is, by the way, the way that we kind of have this right now. And the internet, you know, you might get, let's say this is like an API, so you might get some requests from the internet, right? So let's say someone wants to get information about something via your REST API, for example. And then the container will send back that information. It also might have some other containers that it makes some requests to, right? So this is kind of how our system is set up right now. And what happens is that, let's say that we want to then go and add a sidecar to this. So we still have our application container, and then we have this interacting with our sidecar container. And let's say in the example that this is the HTTPS or HTTP thing, right? So we still have the internet here. The internet still makes requests, but now it makes requests to the sidecar. We still respond to those requests, and we still have those other containers that we might be kind of interacting with in the background. The thing that's really important here is that we have to understand that really everything happens through APIs, right? Or just interfaces in general. And so what's really, really important to note here is that we have to give consideration to the fact that our sidecar container is going to be interacting with its world, whether that be accepting requests in the form of this arrow from the internet, that top arrow that goes to the sidecar container, or returning requests going back the other way. And so something that is really important to note here is that changes in our API need to be done in a manner that is consistent with changes in the application. So let's say, for example, that we have an application that in the API takes in a number, but we represent that number as a string, right? So we'd have like the number 5, let's say, in quotes, right? It'd be a string. And the application is also expecting that number, even though it looks like a number to us, people, the computer, it's expecting a string value type for that number. If we were to go and say in the API, well, we actually want it to be an integer now, or a number type, right? And so we were to take away those quotes, right? We would now kind of have a different type here. Not kind of. We would have a different type here. We'd be working with different types of data. And this is really problematic, potentially problematic, I guess I should say, because if we don't update the application itself accordingly, we're going to break it. It'll be a breaking change, and that is pretty bad. So we need to understand how the API or how the container itself interacts with the world around it, whether that's other developers making API requests to our container or ourselves within our system making API requests to different containers. Let's talk about now container documentation. And this is the last thing that I want to talk about, but it's really, really important. We have to have documentation. This is the same for any software that we write, whether it be the README of, let's say a third-party module or package that you're going to create for other people to use in the open source community, or just the container that you're going to be putting out there for your system to use and other people that help you develop your system to use. This is really important because a container, but more largely on a broader scale, software that doesn't tell people what it is, what it does, how it works, and how to use it is pretty much useless. It might as well not exist. And so it's really important that we have documentation so that other people can understand those 4 big questions, but also other ones as well that I'm just not really thinking of off the top of my head right now. A good place to do this for a Docker container is a Docker file. Well, I shouldn't say a good place to do this. A good place to start is the Docker file, because this is actually what defines everything that that makes the container, right? This is where the container layer by layer is actually built, right? And then the next thing that we can do is using comments, right? You can have comments, I believe, inside of a Docker file, just like you can have comments inside of your code in general. And this is something that we want to make sure that we're using to the best of our ability and in the most useful and understandable way possible for other people. So I hope this video was really helpful for you guys. It certainly helped me to understand what sidecars are and how they work a little bit more. In the next video, which I forgot to make the slide for the next video, but in the next video we're going to be going over ambassadors and what those are and how they work. And I'm really excited for that, so that'll be coming out next week. If you guys enjoyed this video, let me know down below in the comments, or maybe liking the video, or, well, maybe not or, but and also drop me a subscription if that doesn't make any sense. Also subscribe to the channel if you think that this type of content will be helpful for you in the future. Take care, guys, and I hope you're having a great day. Peace.